Hello everyone, in this video presentation I will present my final project, which is the water level measurement using Arduino. In this video, its topic is divided into its own parts. First, there is an introduction and then a list of components, installation and calibration, experiment and analysis, and finally the conclusion. For the first part, we will talk about the introduction. A water level measurement system is a system for measuring the water level in a container. This tool uses a help of Arduino to process data into water level data that human can understand. These tools use a laser sensor with a time of flight principle to read the water level, which will be sent to the Arduino. The process of measuring the water level is to find the distance between the sensor position and the water surface, which will be later be reduced by the height of the container. By using the help of microcontroller and also a laser sensor, the data and the result obtained will be easier and faster. For this part, we will talk about the list of the components. The first of these tools use Arduino Uno, and then we use also VL53L0X time of flight laser sensor, and then we use L2C LCD display, and after that we use male to male jumper cable, and then male to female jumper cable, and the last is the breadboard. For the third part, we will discuss about the installation and calibration. So the image on this slide shows the flowchart of working principle of these tools. The way these tools work is very simple. First, the VL53L0X laser sensor will read the distance between the water and the sensor. Then the distance signal obtained from the sensor is then converted using the time of flight principle in the laser sensor and then become a digital signal. Then the Arduino process the data from the sensor and convert it into the height of the water, and the output value then show the serial monitor and then show in the serial monitor in Arduino IDE. The two images in this slide show how the device is attached to the container, which is a bucket filled with water. The tools and components are then installed according to the direction of the image, and the position of the sensor must be placed parallel to the top of the bucket and in 90° down to get the accurate result. For the Arduino location, it is attached to the breadboard, and the breadboard is attached to the side of the bucket. Next, what needs to be done first when installing is installing the jumper cable on the ground and also the 5V input, which is connected to the Arduino and also the breadboard. Then analog pins A5 and A4 are connected to the breadboard as shown in the slide. On the back of the L2C LCD screen, there are pins that show 5V, GND, SDA, and STL. Its point is connected to the pin on the breadboard according to the picture on the slide. Next, at the top of the laser sensor, there are also pins like the previous LCD. The pins are then fixed to the position shown in the slide. For this picture, this one is the overview of how the whole system is working in this system, in these tools, I mean. This video is a calibration process of the system. At this time, I calibrate the sensor with a ruler to make it measure the same length as the ruler did. I use 13 cm reference length in all the ruler and then see what the sensor read. As the result, the sensor gives a result almost 13 cm as the ruler did. But the result sometimes almost reaching 14 cm because my hand is moving. Next, Next, I prepare a small bucket and fill it with water. I measure the height of the bucket and I get 10 cm. I also measure the height of the water using roller and it get 6.5 cm. In this slide is the Arduino code that I use to measure the height of the water. The next one is about the experiment and analysis. This one is the measurement process of the system. To measure the height of the water, I use the following formula: height equals to bucket height minus sensor read. I hold the sensor and position it on the top, and using the roller to hold my hand on the top surface of the bucket. In this video, the result sometimes going far from the real measurement because my hand is moving. But the right after video, I try to measure it again and get the result and put it in the table. This is the result from the measurement after the video, and I measure 41 data. I put the data on the table and calculate all the average annual data and I get 6.2 cm. Here is how I find the uncertainties of the sensor. Based on the data obtained, the average obtained is 62.22, which is this one. And then I use 75 confidence level as for the calculation, and also I use 41 data from this one and get all this result. Then I input all the values to get the y here. This one I got the y, this one, and then after that I need to find the value of sy bar here. I input the sy, which is 1.585 and divided by the root of n, and I get this one for sy bar. After that I need to find the s bar. I put all the value, the average, and then this one I still using the 75 confidence level, and we'll get this value. After that we just plus this value or minus this value, and then we'll get the y prime max and also y prime minimum. And after that I need to find the value of UC. The UC here stand for the uncertainty of the sensor. To find this, to find the design uncertainty, I need first to find the uncertainty of the sensor first, and then also need to find the resolution for the device I need, and for the instrument I use. And this one I use a ruler, so that's why I got 0.5. After that I input all the value in this one to find the design and uncertainty, and then I got this one plus minus 2.32. For the last part, which is the conclusion. A water level measurement system is a project to measure the height of the water using an Arduino and a laser sensor as a measuring aid. Components and installation are carried out by carrying out several procedures such as a wiring and also sensors to the Arduino. The calibration process is carried out using a ruler as a reference length to measure the water level. When conducting the experiment, the average results obtained from the several experiments prove that the experimental results are close to the actual water level. After conducting the analysis uncertainties, it can be seen that there is an uncertainties in the sensor which is cause the calculation which the calculation using the sensor to be less precise. That's all for this presentation, and thank you.